Hello, everybody, and welcome back to Thinking Pack episode. Uh, what was it? 8? Yeah, I think it was 8. Welcome back to Thinking Pack episode 8. So, last time we started out with this little thing over here, this in front of me that I can't actually put right in front of me because the camera keeps zooming into me. Oh, wait, what if I go up like that? There we go. Yeah, this thing is over here. Anyways, so that. Last time we started working on programming in the Computercraft mod inside of Minecraft, and so we talked about a lot of different things, and I started realizing I don't think I actually gave sort of an overview of how programming works very well. Maybe I did, I don't know. But anyways, I don't think I did. So I'm going to start off with that a little bit, but I'm just going to quickly mention the things that we did last episode. So we talked about variables, we talked about loops, we talked about different kinds of values, number values, and string values, which is basically just a piece of text. And yeah, that kind of stuff. So we talked about all that last time. And if you don't know what that stuff is, then yeah. We talked about that last time, so I'm not really going to get into explaining it this time. So if you want to learn about that stuff, then go ahead and watch the last episode. But anyway, so I'm going to try to give a little bit of an overview as to how the programming works in this episode. And then, like, next episode, we're hopefully going to be ready to actually take on the project that I'm planning to do. So yeah, so anyways, so basically, as far as writing a program, with those basic tools, yay, the sun's coming up. With those basic tools that I talked about last time, there's plus a couple more that we're going to talk about this time. You can do basically anything you want to do in the programming. Like, you can make these turtles do almost anything you want to do. So now, as far as so type dir, that stands for directory, and this shows us what programs we have on the turtle right now. So rom there is not anything we're interested in right now. So this program, trying stuff, is the program that we just were working on last time. So just to recap a little bit. So if we run that program, the turtle just starts like spinning. That's basically all it's doing. So terminate. Oh yes, and one thing that I forgot to say last episode is that there's 3 key commands to sort of control this turtle that would be extremely helpful to know if you want to actually do anything with it. So there's 3 key commands. Control R restarts the turtle, Control T terminates the program, and Control S shuts down the turtle. And those were probably out of order. But anyways, there's no particular order, but it's just which order they make the most sense in. But anyways, so, and what I forgot to say is that you have to hold the keys until it actually does it. So, like, hold the keys for a few seconds. So, like, if I run trying stuff again, then you can see that it's spinning again. And then I have to hold, so press Control T, and you have to hold Control T, there we go, until it says terminated. So you can do the same thing, Control R, you have to hold it for a couple seconds, and then you can see it just restarted and cleared the screen and everything. And then Control S, you hold that for a couple seconds, and it just shuts down. So now the turtle is shut down. And all we have to do is right click on it again, and it turns back on. So yeah. So anyways, so that's basically what I forgot to say about the keys. But anyways, I was going to give an overview of basically the programming, like sort of how to program in general, at least as far as I've learned, because I'm definitely not the most skilled person in the world by far at programming, but I know a little bit. So hopefully it'll be just enough to get you kind of moving and get started on understanding the stuff. So that's basically my goal. And if that works out, then that would be wonderful. So, yeah. And again, like I said this last time too, but if anything I'm saying this episode really doesn't make sense or whatever, just you can leave a comment asking me about it, and I will attempt to I'll attempt to try to explain it better, but if you want, but yeah, we'll see. Anyways, we'll see how that goes, because I've never actually tried to answer a question like that in the comments before, I don't think. So my skills at explaining things over text are not the greatest, so I probably we'll see how it goes. But if you wanna leave a comment, if anything doesn't make sense, then I'll see what I can do. But anyways, so for writing a program, so this is the program that we had last time. Basically, what I wanted to say was that there are a lot of different ways to write a program, and basically the key is that it works and that it always works. So basically, there's different ways you can write it that are like that require more writing, or like, well, not writing, I guess it's type. Well, I guess you could you call it writing if you're typing in program? I don't know. I don't even know. But anyways, so there are ways to write the program that requires more typing, and ways that require less typing, ways that run faster on the computer, ways that run slower on the computer, different things like that. But really none of that matters as long as it works, and it always works. So like, also there are ways that are easier to understand. So like if you're trying to show your program to someone so that they can read it or whatever, or if you're even like trying to get back to it after like several months or whatever, and you don't remember how you made the program and you're trying to understand it again, there are ways that are easier to understand, ways that are harder to understand, different things like that. So, but the key is that it works and that it always works. And also, last episode, I was kind of unintentionally, but it kind of worked out well. I was demonstrating that when things don't work the first time, just keep trying. And yeah, so yeah, just basically, if things don't work the first time, just keep trying. Try different ways to do it, whatever ways you can possibly think of that might work, and do research. And one thing that happened last time, if you didn't see the episode, is that I was trying to explain something, and then I was going along, and then all of a sudden, like, it didn't work when I thought it would work, and I still have a couple ideas what I did wrong, but I'm not really sure. And I did stop and do some research last time, but I only spent about like 5 minutes or 2 or 3 minutes maybe on the research because I was kind of in a rush. But so I didn't end up getting it figured out. But but that's an option you can do if things don't make any sense or whatever. But anyways, so basically, yeah, so as long as it works, and it always works, you can do whatever you want to write a program. So basically, that's an overview of programming. And so now we're going to talk about a couple of things that are left over, like that I didn't talk about last time, which go by the name of functions and if statements, not necessarily in that order. But not the phrase "not necessarily in that order" is not a name, although it could be a name actually. But actually, that talks about the next point that I wanted to say in the overview of programming that I didn't. I don't think I explained very clearly, at least if I explained it last time. I don't remember. But is the commands and stuff that you write in here are the different commands, like through the program. Basically, it starts at the top and goes all the way to the end, and then stops. so it starts first line, then goes. So in this case, what it does is it does the first line, then it checks the next line. It says repeat, so it's like, oh, now I know I'm looking for a repeat thing, and then it does the next line, which has a command for it there, and then it does the next line, which is like the end of the repeat. It knows it's looking for. As soon as it sees the word repeat up here, it knows that it's looking for the word until, basically. But basically, it starts at the beginning and goes through to the end, and this happens to be a repeat. So then it goes back up to repeat, and then does it again, and stuff like that. And basically, so the program, it starts at the top and goes through to the end, and then when it reaches the end, if it reaches the end, then it's done. The only reason it wouldn't reach the end is, well, either because of an error of some kind, or because you just like put in, like I did, an infinite repeat or something that it doesn't ever finish. But anyway, so yeah, so it starts at the top, goes right to the end, and it does exactly what you tell it to do. No more and no less. And that's down to the exact character. So if you get like one character wrong, then it'll tell you like, something's wrong here and everything. So like, let's say here, we know this program works, we just saw it in action. So let's say if I deleted this bracket here, so let's say I forgot to put that bracket in. So save, exit, restart, and run trying stuff, and now BIOS :14 : string trying stuff. That 4 basically means line 4. Unexpected symbol. So this basically, the computer's like, oh, there's a symbol I wasn't expecting that is there. I'm not exactly sure which one it was referring to, but basically the idea is it's saying something's wrong on line 4. So if you check, whoops, that's not what I wanted to do. I wanted to edit trying stuff. There we go. So if we check line, oh, it says unexpected symbol on line 4. So, okay, so I think what's happening here, the turtle sees the open bracket there, and it's looking for a close bracket, and so it assumes that this whole next line is all part of the same, like, bracket phrase or something. Actually, they're not called brackets, they're called parentheses, aren't they? But anyways, so I think that's what's going on, is that the turtle sees there's no closed bracket. So, like, the those error messages, they give you sort of a general idea what you're looking for. So, like, if you have, like, a 73-line program or something like that, and it says, oh, there's a problem on, like, line 52 or something like that, it's probably pretty close to line 52, or at least it's related to it. But just looking at line 52, you can kind of get an idea of where the problem might be. So in this case, it says on line 4, which is this line, there's an unexpected symbol. And there's actually this line, there's nothing wrong with this line because you're just seeing that it works all the time. It happens to be this line, doesn't have a close bracket on it, so the turtle keeps looking for, like, it includes the second line as part of the bracket phrase and all that kind of. Actually, out of curiosity, if I put the bracket down here, what does it do? Okay, let's find out. Restart, and trying stuff. What's it say now? String trying stuff. Number 4, unexpected symbol. Okay, so yeah. So that's another way you can tell, is if I go edit again. So it says, still says on line 4, unexpected symbol. Yeah, so you can kind of get clues as to how it works that way. So that's basically it. So save and exit. And in case you're wondering why I restart the turtle, it's probably not necessary as of this point, but basically, is it nighttime already? Yeah, it's nighttime already, okay. It's probably not necessary with this simple program, but basically it can help to, like, if you have variables or whatever, which I kind of explained last time, but if you have a lot of variables in your program that, let's say, they change along the way as your program goes or whatever, they might be different values or whatever. Basically, restarting the turtle clears all the variables, so it sets it all back to the way the program was intended to be run when you start it. So basically that's what restarting the turtle does, is it resets all your variables, and so it just helps to make it, what's the word I'm looking for? Simpler, I guess, for when you're having errors and stuff. It sort of simplifies the process of trying to figure out what's wrong. So that's and I've actually had that happen to me before, where all of a sudden like variables will be the wrong value or whatever when I start because I didn't restart the turtle. So anyway, so that's just, it's kind of a good thing to do. Anyway, so that is talking about turtle commands, and we talked about loops last time, 3 different kinds of loops. We talked about variables last time. We talked about values except for one value, which has kind of a fancy name. That's not the command I want. I want to edit trying stuff. There's a variable that has the name that is called a Boolean, is what it's called, and I think that's spelled Boolean, but I'm not entirely sure. But anyways, basically a Boolean is basically a value that it's either true or false. So basically, like, let's say I change this loop back to a while loop. So last time I did while 0 is equal to 0, do, there we go, and end. Okay, so last time I did that. So this will do exactly the same thing as that particular repeat loop that we had. But so basically, like, if we restart the turtle and then run trying stuff. There we go. If we run trying stuff, you can see it just keeps spinning around like that and kind of jumping a little bit. I'm not entirely sure why it's doing that, but anyways. So, excuse me. So, trying stuff. What was I saying? Oh, yeah. So, basically, it's an infinite loop because what it's doing is it's checking 0 is equal to 0. Well, 0 is equal to 0, do this. And so 0 is always equal to 0, so it just keeps doing that. But we can also put in a Boolean value if we want, which is either true or false. So we can say, well, true, do. So it will check if true is true. And of course, true is true. So then it will do what to do if true is true. So if we save and exit and restart and run trying stuff, you can see it keeps doing, because it just keeps checking that true is equal to true. True is true. So, and in case you're wondering, that's true. So anyways, well, true, do. So basically, yeah, so it kind of, I always found it was harder to make sense of that in this particular context, so that's why I always do 0 is equal to 0. I suppose I can't say always, but usually. But it'll make sense in some other contexts. That's not a word, I don't think. But it'll make sense in other contexts as we go along. But anyways, so back to what I originally said we're going to be talking about this time. If statements and functions. So if statements, basically what we can do is we can tell it, if such and such a thing, then do this, but otherwise do another thing. So we can kind of like give it some, I guess you could call that some intelligence. But anyways, so like, let's say, first let's turn this. So exit, I'm just going to type go right. So here we go. So basically what we can do is we can tell it, so basically, let's say we want it to go forward, so it's on this track here. So let's say we want it to go forward, and keep going forward until, let's get out of the water here. Okay, keep going forward until we reach a block. And then as soon as we run into a block, then turn right, and then keep going. So let's say we wanted to do that. So let's go over here and let's start writing an if statement. So if statements, I think I sort of said this already, but basically it's basically like it sounds. It says if something's true, then do that. So why don't we put it inside our loop here? So it checks if 0 is equal to 0, and then we want it to check if, and let's say, okay, I didn't actually figure out which commands I want to use. So, oh, I think there's a command, was it turtle.detect? Is that the one? Well, I guess we'll find out. If turtle.detect, Actually, let's start with another example that's a little easier to understand. So, let's say we want it to, so I'm not sure if this is easier to understand, but anyways, let's start with, let's create any variable. So a variable, let's say, let's call it, why don't we call it variable? There we go. Very creative names here. Variable is equal to 0, let's say. And then we want, every time it starts this loop, we want it to take variable. That's not how you spell variable. There we go. We want it to take variable. And here's another thing you can do with variables in programming is you can take variable is equal to, so you can tell it variable equals, and then variable plus 1. And so let's put a space there just for readability. But anyways, so basically what this does is it basically starts in this line, and sets variable to 0, and then it goes down here and it does an addition, and it takes this here is what variable was before, which is 0, and it adds 1 to it. So basically this is, you can, I'm not exactly sure how to explain this, but basically you can make any variable. Let's make it something that's less confusing because I'm talking about variables all over the place. Let's just say x. So x, and then change this to x, and change this to x. And so basically what this can do is sets x to 0 in the first place, and then afterwards it will rewrite x with saying what x was in the first place plus 1. So, and then, so basically now x will equal 1 over here is where it sets it. So x equals 1. And so then it goes down, and then it goes through the loop again, and the next time it gets to it, x is already 1. So 1 plus 1 is 2, and then it goes to the end, and then you keep doing it, so it'll keep adding 1 to it. So basically that's basically a thing that it can do. If that makes any sense. I don't think that explanation was very good. But anyways, so now we can do a check. So like if x is equal to, see, the problem with this explanation, I'm thinking, is that someone is probably going to think, like I just did, that, well, you can do this exact thing with a for loop, what I'm about to do. And yeah, you can do this exact thing with a for loop. And I can't think, I use this all the time, but I can't think of a good example of when you would want to use this kind of a system. But anyways, so just take this as an example that you can do this. But anyways, so now if x is equal to, when I say do this, I'm talking about doing the x is equal to x plus 1 and everything like that, going every time the loop goes. You can do that with a for loop. But anyways, this is just an example. So we can check if x is equal to, let's say, 10. Then let's tell the turtle to turtle.forward. Why not? So turtle.forward. So here, let me write it and then I'll explain it. It should make more sense that way. So then, and then we got and I don't actually want it to do both of these things at once. So let's set this else and okay. So there, so I just wrote it. So now I'm gonna try to explain it a little better, and I'm just gonna give it some space so that you can see more clearly what I'm doing here. So this section here is the if statement. So basically, it will check if x is equal to 10, and if it is equal to 10, then it'll go forward. And if x isn't equal to 10, then it'll turn right, basically. And so this is an if statement, basically. If x is equal to 10, then go forward, and otherwise turn right, else turn right. And so that's basically an if statement. And you can use that to do all kinds of things. So what this will do is every time the loop goes around, it will keep increasing the value of x, and let me just back up a bit. It'll keep increasing the value of x, and as soon as x equals 10, when it goes through, then it will go forward. But every other time it'll turn right. And then x will keep going up. It'll go past 10, it'll just keep going, and so it'll just keep turning right. So you may think, what's the point of this program? And I have no idea except to demonstrate the thing. So anyways, if we run this, now we can see it does its turning right thing, and then it goes forward on the 10th time, and then it just keeps turning right. And so here, if I edit again, so I can show you, actually, I almost forgot about this, I can show you what's going on if I tell it, so the first thing I tell it to do is print the value of x. So basically, it writes it to the screen. So we can sort of tell what's going on. So basically, it'll keep, every time it runs that print line, every time it goes through the loop, it will print to the screen what the value of x is. So trying stuff, and we can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so it keeps going like that. And you can see it just moved farther away from me because on the 10th time it moved forward. And so here we go. So x just keeps going up. And it will keep going up infinitely. So let's stop it because we don't have an infinite amount of time to wait. So basically, so this is an if statement. So let's forget all this x stuff. Let's get rid of all that. And let's go back to the original example of just the if statement on going forward. So this is going to run into a tree here. So I'm going to tell it to go right, so it turns, go forwards, and then go left. There we go. So now it's back in line so it won't run into a tree. So basically what we want it to do, so I'm going to demonstrate the if statement. This probably would have been the best idea in the first place, but anyways. So I'm going to demonstrate the if statement this way. So I'm going to clear out these lines here. And there we go. And let's see. Get rid of x equals 10. Okay, so let's see what we want it to do. We want it to go forward until it hits a block, and then when it hits a block, we want it to turn right and then keep going forward. So there's an easy way we can do that. So we can have the turtle detect if there's a block in front of it. So basically what we can do is we can have it keep going until it detects that there's a block in front of it. Then when it detects that there's a block in front of it over there, it looked like my arm was coming disconnected from my shoulder. That's weird. But anyways, we can have it go along until it detects that there's a block over there, and then turn right. And then it won't detect a block anymore because there won't be a block in front of it because it won't be facing a different way. So then it'll keep going. And so basically we can have it do that. So let's say if, and I'm going to do this a way that's a little easier to read. So let's make a variable. Let's call it isBlock. IsBlock is equal to turtle. I think I'm doing this wrong. Hang on. Turtle.detect. And so turtle.detect, basically there's a command. You can look all these commands up on the Computercraft Wiki as well. But so turtle.detect, basically, I think that's the one that it detects if there's a block in front of the turtle. And if I'm doing this right, which I don't think I am, then, and I'll fix that in a minute if I'm not doing it right. But isBlock equals turtle.detect. So basically, what this should do is it should check, it should, basically this variable here, isBlock, should get a true or false value. So basically, if turtle.detect finds a block, it will be true, and if it doesn't find a block, it'll be false. And then we can use that if isBlock, then do this stuff. So basically, if isBlock is true, then do this stuff. So if isBlock, turtle, if I can type properly, .forward, and otherwise, if isBlock isn't true, then whoa, wrong command. If isBlock is true, sorry, if isBlock is true, then turtle.turn. That's not how you spell turn. That's not how you spell turn either. Turn right. Okay, so if isBlock is true, then turtle.turnRight. Otherwise, turtle.forward. There we go. So what this will do, if I did this right, and I think I did this line 3, I think I did this wrong. We'll find out in a second. But if isBlock is true, then turn right. Otherwise, go forward. So restart, run trying stuff, and it just turned left because I forgot to remove that line. Oh, I did it right? Well, that's amazing. Okay. So anyways, yeah, so basically that's another example of if you think you might be right, but you think you might be wrong, you're not really sure, you can just try it and see if it works, and if it doesn't work, then look it up or try a different way or something like that. But yeah, so basically that works. So you can just give it a command like that, and the turtle's just going to push the pig into the pond. Anyways, so it's going to keep going. It's noticing all these like tall grass and everything as blocks, so it keeps running into them. So anyways, so this is the thing. So it keeps checking, and it keeps checking if there's a block, and if isBlock is true, then it will turn, basically. And so that's what this does. So yeah. So that's another example of just go ahead and try it if you think you might be right, might be wrong, not sure. And you'll find out because it always does exactly what you tell it to do as it understands it. So yeah, so it's a pretty reliable way to tell. Anyways, this might get interesting if it gets stuck in the grass here. And it didn't really get stuck, it just turned around. Oh, can I actually ride the turtle? That would be interesting to tell. So basically, that is an if statement, simply put. And this episode has already been quite long, but I have just one more thing to cover, and apparently it doesn't count water as blocks. It's just going right through the water. Anyways, so out it goes, and it's going to keep going. So I think I just have one more thing to cover. Let me check my notes here. But yes, so we got, where's the turtle? There's the turtle. Come back here, you. So the only thing we got left is functions. So basically a function is actually quite simple. There's a slight bit of language that you need to know to be able to do it, but the concept is actually really, really simple. It's just basically when you want it to be able to run a piece of code, like anytime you want. Like, let's say that whole thing I just wrote about being able to go until it runs into something and then turn and everything like that. If that's part of your program, but you also want it to be able to do other things, then you can write a function for it. And I'm going to give an example that is probably quite pointless, but it just sort of demonstrates how the function works. So let's stop, terminate. Thank you. Okay, before it runs away. So let's edit trying stuff again. So basically, if you want to run a section of code when you want it to run, instead of when you don't want it to run, then you can do this. So basically, if you take, let's get rid of this turn left line to start, just because we don't need that anymore. So let's say this whole thing that I just wrote, and I'm gonna clean it up a little bit. I'm just gonna get rid of the, there we go. So now it's all in one section, and there's nothing actually down here. It's just carriage returns. So this whole section, we can say function and give it a function name. So let's call it, oh, I'm not good at function names. Actually, I'm not good at names in general. Anyways, let's call it a function of bump into things. Bump into things. There we go. Open bracket, close bracket again. And down here at the end, let's tell it this is where to end the function. And I'm just going to indent all this just so that it's easier to read. There we go. So, function, bump into things. So basically, what this does is everything that's within this, so I'm going to actually space it out so that you can see it better. Everything that's within this section here will be run when I type bump into things. So basically what that means, where was I wanting to go? I forgot what I was going to say. That's not very good when you're trying to explain things. So yeah, so everything that's inside here will run when I tell it to bump into. Oh yeah, so I wanted to say, now that I've said function, so it'll treat this as a function is basically what it is, but it will not run this code actually by default. So it'll like load it or whatever it needs to do, but it won't actually run it. So like if I say trying stuff again, you can see it's done. Because all it really did was it loaded this, I don't know if it loads it into the memory or what it does, but basically it read through this, but it didn't actually do anything with it. So bump into things, what we have to actually do now that we've made it a function is we need to type down here bump into things. There we go. Save. So now that we've told it down there to run bump into things, then we can do trying stuff again, and now it'll go, and I want it to stop. Stop. Thank you. And actually this, if I remember right, I'm probably going to make myself look stupid again, but if I remember right, this is useful for, we make this a function, and I think, now that it's a function, so if we restart, if we run the program again, it doesn't do anything, but I think at this point, if we type bump into things, it will do something, or maybe not. Into things. Wait. Oh, break the loop. Okay. So there's something I'm doing wrong. There's a way to do that, though, where you can type in... At least I think there is. Anyways, yeah. As I said, it would probably make myself look stupid. But anyways, so that's another example of how just try what you think works and see if it works. So anyways, so back to the point. The point was, so now that it's a function, we can type the function name down here, bump into things and whatever, and it will run it and it'll do that and it'll all be good. And let's just, I'm going to take off this infinite loop, otherwise it'll never stop. Let's make this a for loop, just so that it does stop. For I is equal to 1 to, let's say, 200. And do, there we go. And we already have the end down at the bottom here. It's this particular end that connects to that for. So anyways, so now it'll loop only 200 times rather than being infinite, so it won't get stuck in here. But anyways, so that was all to prepare for this example. So what we can do now is we can take our function name, bump into things, and put it down here. We can write another function. So let's say function, that's not how you spell function. There we go, function. And let's call it, well, actually, before we know what to call it, let's figure out what we want it to do. So let's say spin on the spot. So let's say spin. That's where the function ends, and everything in the middle will be run during this function. So let's do another for. So let's say 9 times. No, for I equals 1 to 9. Do, and this is where you end the for loop. And why don't we say turn right? Or, no, turn left, because we were doing turn right before. Ha ha ha. Turn, whoop, sorry, wrong command. Turtle dot turn left. There we go. So basically now what this will do, it has a function, whoops, space, okay. It has a function up here, bump into things, which does, it goes around until it finds a block and then it turns. And the spin function will basically turn around 9 times, and then it'll be done the spin function. And down here, we can tell it, bump into things, we can tell it spin. And so now, as you can see, restart the turtle and run trying stuff. So now, it will run that first function that we put there, and it will go forward. And then we changed it so that it doesn't go infinite. It'll only go 200 times through the loop of checking for things to bump into, I guess we could call it. So it'll go 200 times. So you can see there, oh, and it just turned back around. And so it'll keep going. And then when it does 200 times, then it will go to the next line, which said to run the spin function. And so then it will do all that spin stuff. And so basically I guess it doesn't look all that useful right now, but once we get into like actual real programming or whatever, then it, like actual practical programming, it becomes a whole lot more useful. And we just sort of stuck it in a line where it just keeps rotating back and forth. But anyways, it'll only go 200 times. Then it will spin, and with 9 times, it will turn a different direction by the time it's done spinning and head off that way. So I don't actually know when 200 times will be up, because I didn't actually code in like I did before where it would display the number all the time. I didn't actually code that into it, as you saw. So there we go. So here it's spinning around 9 times. And it stops. So that's exactly what we told it to do. So we have the function of bump into things. So basically every time we type bump into things into the program, it'll run all this code up until the end here. Excuse me. And every time we type spin, it will run all this code up to the end here. And so then down here, we typed bump into things, we typed spin. We could even do it again, so bump into things, and we could type bump into things again, or whatever, but I don't want to do that. Basically what I want it to do is I want it to keep doing this infinitely, so where it'll move 200 times trying to find things to bump into, and then it'll spin around somewhat until it's facing a different direction, and then it will find things to bump into again. I want it to do that, just for the sake of example. So we can even down here below the functions that are up at the top here, down here we can tell it to loop while 0 is equal to 0. Whoops, that's not how you type it. There we go. While 0 is equal to 0 do. And so basically what this will do is it will run. It starts at the beginning of the program, of course, so it checks. It finds a function called bump into things, and it checks all this stuff is what bump into things means. It defines the function is what it's called, I think. So, and then function spin, it will define a spin function, and it'll say when I type spin, do all this stuff. And so basically it just reads that so that it knows what those things mean. And then it goes down here, and well, 0 is equal to 0, so it'll just keep like looping this. So then it will run, it will do bump into things, and it already knows what that means because we defined it. Here's another thing actually, that it's best if you define your functions at the beginning of the program, because if you do it afterwards, then it won't know what it means yet, so it'll throw you an error. So it's best if you define your functions first, and then run your code down at the bottom so that it actually knows what it means when you say things. But basically, so now we just type bump into things, and we type spin, and it'll keep looping them. It'll keep doing them over and over again. And I don't think I really need to demonstrate that because we already, you already know how loops work. But anyways, so so that's basically functions. And I think there was something else I wanted to explain, but about functions, but I'm not really sure what it was that I was thinking to explain. But anyways, so if in this whole tutorial thing and everything, if there's some stuff that I forgot that's kind of important, or if you have any questions or whatever, leave a comment, and I will try to I'll see what I can do to help make it make more sense or whatever. But anyways, so yeah, so we're gonna basically, the plan is next time we're gonna take all of this information that we just learned about all this and all these basic tools, and we'll take them and use them in a project. So we'll actually get some practical use out of this particular excuse me, this particular thing that we're doing here. So yeah, so hopefully you enjoyed the video, and come back next time if you want to see us actually do a project with all this stuff. But anyways, yeah, so hope you enjoyed the video, and see you later. Bye-bye.